Hi everyone, it's Frederick, the MicroHobbyist, and I decided to do this impromptu stream just for the fun of it. So it's only me coding in the Arduino IDE, so I could do a um, basically a sort of logic analyzer for the 6309. I've built a few pieces of the circuit and I want to test it out. And I'm doing a sort of a virtual NOP test. So I'll be coding things as we go. And if it's not working out, then I'll be ending the stream. But if people want to join in, let me know. So let me go to the screen. I should program a button for that. There. So basically, I'm starting from scratch. And I haven't programmed anything in ages in Arduino. So I will be doing, let me check if everything is up and running on YouTube. Make sure I don't do this for nothing. Let me see, content. Live, yes, and we are live. Cool. All right. So obviously nobody is there now, but maybe somebody's going to end up watching it. All right. So I do have a few notes. One thing I want to do is, number one, what I want to do is I wanted to do a variable speed using a potentiometer, but I think I'll just do it straight with like at 10 hertz. Maybe it'll be good enough. So what I need to do is, first of all, I should have done a plan for this. All right, so I'm going to create a software clock. So, and I'm going to, I'm going to make sure that I have some sort of clock system. I believe it starts, like I told you, it was a while ago. So unsigned, long. I know there's the classical C. I could have put uint 32 underscore T, but unsigned long will be good enough. So unsigned long. Let me see if there's anybody coming in, just to make sure that if someone's on the green room. Nope, nobody's there. I sent out an invitation just for the fun of it, but if anybody is commenting out there, please, you can join in if you want. Unsigned long, it will be the current millisecond, current millis, and this is microseconds equals micros. I love this new language. It just tells you exactly what to put. So I get this. Then what I want to do is keep the period steady. Or do I don't care about if the period is steady or not. It's going too slow for that. So if the clock level, I should probably declare a variable. Yeah, so I should declare a variable, which is a global clock level. If global Let's start with I think I should start with the function. It's going to be easier, then I'll be able to add on to it. I'm just going at it the reverse, the wrong way. First of all, I need to create clock pin. I got some notes here. I should probably just put it aside like so. And change this like that. There. Okay, I'm going to start with I need to declare the variables. Doc, I need not in a setup, but the variables constant. The pin should be byte, unsigned byte. Unsigned byte, pin clock equals 4. That's where it's plugged in right now. That's why I know it's 4. I'll need constant unsigned another byte because I will use the integrated LED of the Arduino Mega. Pin LED equals, and now it's 13. I believe it's 13. And then I will need constant unsigned byte for a pin E for the E clock, and that will be pin number 2. And I need to find out what are the addresses, what the address is. I took a note of it. That's what I'm looking at right now. So we've got the constant unsigned byte. Pin address. Address. There is 16 of it, 16 entries equal. This is really an impromptu thing. I have not prepared anything. So it will be pins 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, whoops, 30, 31, 32, 33, 34, 35, 36, and 37. There, close that. All right, then, oh, it's already closed. No. Data. The data need to do the data. I was looking at the status of YouTube and if somebody was in the green room or not. Constant, unsigned, byte, pin, data. God, I'm bad at typing. 8 equals, open curly brackets, and it will be 38, 39, 40, 41, 42, 42. Are my levels okay? My mute are not good. Yeah, okay, still there. Okay, perfect. I will increase the volume just in case. There. 42, 45, no, 42, 42, 42, 44, 43, and 44, and 1, 2, 3, 4, 45. All right. Semicolon. All right. Now, what other variables do I need? I believe I shall need. We'll see as we go along. I'll need to read the address bus. So let's do a function. Static long unsigned long read address bus. And then I need, let's see, trying to recollect. Trust me, when I put this in the video, it's going to be a lot shorter. Actually, it's going to be something else. I'm not going to put it as is. It's going to be too long. And me thinking about what to code, no. You don't want to see this. If you're here watching presently, is because you want to be going to bed soon. It's going to put you to sleep. All right. Now, enough said about that. I know I'm boring when I'm doing nothing particularly interesting. All right. So now we have. Let me check StreamYard. Anybody there? No. Okay. We'll dream in code. Yes, we will, ABC. Absolutely. Like I told, like at the beginning, I just don't remember how to code in this IDE anymore. I mean, I'm used for the last 3-4 years just to code in assembly. 6502 at first, and then Z80, and then now the 6809 or 6309. And high level, it should be easier, right? Yes, it should be. All right, now what I want to do is create a variable, an output variable. So let's call it unsigned integer at 16 bits. I wonder if it's going to use it as NC. Does the Arduino interpret integer as 16-bit or 32, or 32 is a long? You know what? I'm going to use the old style C standard just to be sure. So unsigned integer 16 underscore t. Yeah, that way I can't make a mistake. And I'll do the same thing for the rest. Let's just do everything like we won't have any surprises. Unsigned integer 16t. Do the same thing for these things here. Let's restart from scratch. So that would be unsigned integer 8t. I believe. Correct me if I'm wrong. I don't have the chat window always open, but I will look at it once in a while. Okay. All right. Uint 8t. No surprises. Uint 8t. Unsigned integer 8 byte. And unsigned integer 8 t. What's t again stand for? Type. Yeah, type. All right. Now I need an output variable. We'll call it address. Is it something that's reserved? No, let's call it address. It's going to be equal to 0. And I need to do a loop, or I can do it, one at a time, but it's going to be like 16 times. It's going to be ridiculous. I'm going to do a loop for, again, oh yeah, that's right. I have to declare everything. That's ridiculous. Uint 8t. Classical I or T or X, whatever, I equals 0. Semicolon or colon, semicolon. I think it's semicolon. We'll try it. We'll compile it, see if it works. So do it until it is smaller than 16. Where's my smaller than 16? I plus plus. Increase by 1. All right. Now I need to make sure that, what do I do? I read the pin, and if it's high, I give it a value. Because right now the value is at 0. Everything's value. Now I want to bitwise each individual bit to their position, to the index. Basically, I is the index. So if it's true, or I just go one by one and set it as is. Well, no, if it's true. Like, so if digital read, is that, yeah, digital read. No, don't put stuff I don't want. I said pin address I, right? And is high. If it's high, so I got my closing bracket here. Got my closing bracket here. No, it doesn't go here. is high, then address equals address bitwise I think there's a way to do it like plus plus. I think it's bitwise. Not sure. Let me Google it. Google Arduino bitwise operations. Okay, got my OR is the, yeah, so, yep, looks correct. All right, I think that's it. I think I had it. So this hey Wayne, you didn't know I was streaming. I didn't know either until like 5 minutes ago. I have to get this on my TV. You don't. You don't want to see my ugly mug on a big screen. And it's at 720p on top of that. It's not great. All right, so where was I? All right, so the address I'm trying to figure out. I want to put a 1, right? 1, and shift it and bit shifted. I think it's these things. No, the other way around. So if it's 1, perfect, and index with the I. Or is it the other way around? I shifted into, no. So 1 shifted into I, or I shifted into 1. I'll have to try it. Hope it works. I think it's that. Let's make it clear, and let's make it unsigned. I think it's that, right? Correct me if I'm wrong. Yeah, it looks like it. And then I believe I have to return a value. So return address. All right, so I got read my address bus. That should work. Save. Let's compile it, see if it works, if it doesn't give us a bug. Whoops. Suggested alternative. Oh, yes, I haven't declared it yet. And the setup that this is a output. Well, it's an input. I mean, it's an output from the CPU, but an input. So I have to go and say, I also have to set up the serial eventually, but it's not connected right to for now, but I'll do it anyways. If I recall, it's serial begin. Serial begin. There it is. Serial begin. 115 200.
That number I remember because I'm using it on my 6309 ACIA. Let's not forget the semicolon. And I have to declare every pin of the address. So for unsigned interrupt 8 equal, no, I equals 0, when I'm going to go I is smaller than 16, and step every plus plus I plus plus step 1. All right. Let's see if there's any comment. Oh, there is comments. Hey, hi Dave, how are you? Can't read the code without putting it on TV. Yeah, of course. I'm sure that it's pretty small on a screen on a phone. Pins are by default inputs. You don't have to declare them, Rinky Dink. Hey Trina. Good question. Pins are by default inputs. Then why did it give me an error? Note, suggest alternative pin mode. I would think that pin, unless I made an error in the actual, if you don't use pin mode, they are inputs. Okay. So why did it give me an error then if it's an input? Maybe the latest version of the IDE absolutely requires you to define it. I don't know. Looks more like a declarator. Yeah, looks like a declaration error. Oh yes, I forgot to delete that. So let's get rid of this setup here. Yep, you're correct, Rinky Dink. That is good. Thank you. All right, so we don't have to touch that anymore. So it's piece of code, one less piece of code to put. All right, next piece I want to do is to write to the data bus. Do I need? No, it's a void one, I think, because I don't need to return anything for the data bus. Or can I put anything? Yeah, no, I need to put a void on it. Void. Write data bus. And it will be uint 8 value. Why not? We'll call it hex value. No, just value. I don't have the comments all the time on screen, so I won't see them live, but I will go once in a while. Even if they are inputs by default, I prefer to explicitly set them to inputs, just my personal preference. Yes, you're correct. I believe that if you start just assuming things, then that may cause problems down the line, especially if there's a change, I guess. All right, where was I? Where was I? Sorry, because I have to go back and forth, and I should have multiple screens, but I do. It's a small screen for the prompter there, which is reversed, so I can't use it, and the other screen over there, it's too far. 3 screens. I could have a fourth one. I do have a fourth board on my card. Kind of overkill. It'd be nice though to have another screen right there so I can reference things. I have plenty of screens downstairs, by the way. You know how we are, us retro people. Kind of hoard equipment here and there. All right, data bus. Like, go back to working. People are watching. All right. So same thing for the address bus. So for integer, no, unsigned integer 8 I equals 0. Of course, compiling makes it does tell you if you have a structural error, but logically, it doesn't tell you if I have a logic error. I won't know until I actually send it to the Arduino if it works or not. Okay, I equals 0, and then do that. I is smaller than 8, right? I should have a beep when someone sends a message. Is there a way to do that, Trina? Beep, message. Be nice, I++, so I can go back and forth without waiting too long. And open curly brackets. So now, I need to enter the value and output it, right? So I need to do basically the reverse, like what I've done before. So declare the variable integer bit. It's a bit. We need to extract a bit, right, from the value. Let's go see if people have ideas. There is not, sadly, unfortunately. Yeah, who doesn't have spare monitors, right, Trina? What am I writing? Yes, yeah. Basically what I'm doing is I'm trying to do a pseudo logic analyzer for the 6309. I'm building a 6309 computer, and right now what I've done is I put the CPU reset circuit. The clock is going to be generated with a PLD, so I can software control it. And I have bus buffers with damping resistors, because depending on the speed I'm going, I may want to dampen want to cut off the overshoot. And what I'm doing basically is I'm going to create a pseudo virtual no operation tester, like I did in my, well, actually I'm doing in the video right now that I'm editing. Actually, in the first episode, I did the NOP tester, but now I want to test if that works correctly. I have, it works with LEDs, fine, but I want to know if it works with the Arduino, because I need the Arduino eventually to test the PLDs, which I'm going to program, which I can't test without some sort of validation system. Because if I start building everything, and then I find out it doesn't work, well, at least with this, if I can make this work with the Arduino, I can make it become some sort of a logic analyzer, but with some sort of intelligence behind, so you don't have to decode all, if you have a logic analyzer with 32 inputs, try to figure out what's what in there. It's really have a big hassle. So that's what I'm doing, basically. You want a mod? You want to be a mod? Why don't you join? I'll send you an invite. Oh, a mod on YouTube. Moderator. Here you go, Trina. Let's see. Where am I? Okay, got to go back to my train of thought. Now I want to grab the first bit of the value. So bit of value is well, the value, right? Of course, using values of value name is not very. Let's call it something more significant. Let's call it. If I call it opcode, it's not really precise. Just leave it at value. Who cares, right? It's like the value A, B, C, D, E, F, G are file names, test 1, test 2, test 3, final 1, final 2. We all know what that is, right? All right, take the value and get to the first bit. Would be, correct me if I'm wrong, this. And I'm reading the value. Do I have to AND it? I know that in assembly, when you want to isolate something, we AND it with a 1 at a specific bit position. Now I'm having the value at the first bit, which would be in this case the one completely at the right. No, it's not 1, it's I. Right. Hey, wait a minute. I. And then I go. Tuk, 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 tuk. And I end it. If it doesn't work, well, it doesn't matter. We'll know soon enough. And end it with 1, unsigned, just to be sure. And I think I have an extra there. Sounds right. Right? I'm going to go switch. Mentally, not up to joining, but thanks for the thought. No problem, Trina. I'm hoping to find time to make my own retro computer one day. I'll probably do a Z80 first, as there are a lot of resources for it. Indeed, you're right. I've done the Z80. I stopped. Heck, I could show you what it looks like. All right, let me go back to there. So this is my Z80 computer. I went overboard. I did not use any PLDs on this one, so I decided to say, well, let me go full screen on this. So basically, this is the clock card, and what I wanted to do is make it variable. So this variable card, let me see, you have several switches and buttons. So I don't remember by heart. You have preset buttons here to say what I want to start in step mode, run mode, fast, and to look it up, they're written somehow. So there, oh yeah, boot mode, single step or free run, boot speed, fast or slow, and then you get reset fast. Okay, when you reset, is it in fast 0 or 1? So you get a 4-bit value. So for the standard boot speed, that is clock selectable, software selectable, I mean. So it's all TTL, and that's a crystal. Which one is that? That's the what crystal? It's a 10 megahertz crystal. Yeah, I'm running at 10 megahertz. Is it? No. It's 7 point something. Because divided by 4, I think you get the ACIA value for standard your standard baud rates. And you have the buttons here for stepper and change the type of clocks you want, and it gives you the values. What are you looking at for the LEDs? So you got your I've written down, but not enough light. So that's the card for the clock, and I'm using a standard 8-bit ISA slots for them. I have a local store which sold them by the droves. I mean, I bought something like 50. And so I built this backplane for it, standard with an on-off switch here and the a barrel connector right there. I also made it so that you can plug in a breadboard directly on it. So you could build something. That's how I built my other cards. I built first the clock, put it on, then I built the CPU on the breadboard, then made the CPU card for this. A CPU card in this particular case has just TTL, also logic, glue logic. It does not use PLDs in this case. My first attempt at using simple glue logic instead. I always use PLDs from the start, and I will continue using PLDs for space saving purposes. So you got your Z80 here. You got your RAM here. It's 512 megs. We're so used to megs, right? Kilobytes of RAM, and you got 128 K of flash memory. And I put it on a ZIF socket, so it's easier to go, need to reprogram it, take it out, put it back in. And then you have here a quad quad communication cards. So you got 2 RS-232, one DTE, the other one DCE. And you got 2 USB, a USB-B and a USB-A on it. What I'm using is the Max 232 for the RS-232, and I'm using, what was it? Can I read it? I think I removed the chip. There's chips missing, right? It's MCP. I'll have to look it up. I believe it's MCP 2221A. It's basically a USB transceiver. It's nothing special. It's not a USB host device. It simply communicates through USB as if it was a serial port. So that's nice. I removed one because I think I needed it for another project. So basically that's it. That's my Z80. And I switched from 6502, and I absolutely love the Z80 because of there's a good quantity of registers, and they're 16-bit compared to the 6502, which are all 8-bit. The only thing 16-bit on there is the program counter. That doesn't count. So do I have any... should be watched your 78. Okay, yes. Unfortunately, I like many things, I didn't have time to finish my series. I sometimes jump the gun, and most of the time my videos in the past were like second thought. So I decided to let's do this and let's do that. I didn't do much videos on the code, but I really expanded the code. I did a big monitor program and an evolve monitor program. It's almost operating system ish. But yeah, you'll love it. But you'll also love the 6809 and more so the 6309 if you ever want to go that route. The reason being is it's got an enormous amount of registers also, but the 6309 has some 32-bit. You can merge 4 8-bit registers to make a 32-bit register and do some 32-bit operations, including addition, subtraction, multiplication, and division. So that's interesting. So you might want to look into that. There, and it doesn't take much to go from Z80 to 6309. Really doesn't. I think though, even though Zilog decided to stop manufacturing, I think you can still get quite easily the Z80, but not the 6309, 6809. You can still get them, and I found a good source for them, and that's UT Source. Is it .net or .com? One of those two. UT Source is in China, but I would say they're more guaranteed to not be fakes. Don't go and try to buy them at AliExpress. I got scammed at AliExpress with a Yamaha V9958. They didn't even try. I mean, the date code on it was 2019. For crying out, you know that a Yamaha is like pre-2000. So, and I compared it. I have other 9958s, and they really don't look the same. You can always, try eBay, but sometimes it's kind of risky also. Currently writing the Arduino libraries for the whole retro computer thing. This is a bit on hold at the moment. What do you want to do with the Arduinos? Try to use them as helper chips, or time? I've heard of her. Yeah. Yeah, hopefully the next series for the rest of the episodes of the 6309 revised edition will be a lot more complete than my other series. Like I said in the past, I just like threw videos around and here. And I wasn't really into strangely enough, I have a video production background, but not in front of the camera. You know very well that I'm not that charismatic to be like a superstar, but I sort of managed to get out of my shell a bit, and also try not to eat my words, because English is not my first language. So post a link to your website. Curious to see them. All right, back to coding. In the meantime, where was I? Now I have to figure out what was I doing. Right, so I'm trying to extract bit by bit the value bit value minus equal the value greater, that's shifting bit shift to I to 0. So go to bit 0, end it with 1. So I flush everything else and put it in bit value. That should be it, right? Correct me if I'm wrong, Rinky Dinky. Rinky Dink? Rinky Dinky. I have to go and look at it again. Yeah, Rinky Dink Electronics. What language is it? Mine's French. I'm still full screen? Oh, yeah. Sorry, you're right. I have to program my Stream Deck to go to this screen. There. All right. Yeah, right here it was minus, corrected it to equal. That's the only thing I changed. Now I need to write to the data pins. So if the value is 1, I need to write high. If the value is low, I need to write low. So basically, go back here. Basically, I need to say if. Wait a minute. Instead of doing an if, couldn't I just do a digital write pin data I and the bit value? Or should bit value be a Boolean for that to work? What do you think? Boolean. Let's try it. Because if otherwise I have to do it if the bit value is 1, then digital write high. If it's 0, else digital write low. Seems to me that I could put, instead of high and low in digital write, I could put the variable. But I think it has to be a Boolean. Let's see, digital write. Let's look it up. Digital write. Digital write. What does it say? It can be an integer, not a Boolean. All right, that's good. Perfect. Let's try that. So digital write pin data I and put bit value. See if someone's screaming saying, "Don't do it." Norwegian. Oh. I think I would do digital pin value on and simply put the formula in it already. Value and yeah. Don't do it. I wonder though, would it somehow, because digital write is not like doing an assembly. I mean, it has a certain. Well, we don't care because we're going too slow, but digital write is not the fastest way to write to an I/O pin on a microcontroller. If I add the expression inside the digital write, wouldn't that slow things down? Rather than just putting the result of which is bit value in this case. Yeah, exactly. It's slow. But in this particular case, it doesn't matter because we're going at maximum 100 hertz. So if we're going faster than that, yes. If I was going to make somehow the microcontroller being a helper for the system, then yes, I'd have to go assembly. So in order for people to read it later, I mean for when I'm going to do my video, I think it's better to separate it, because when you encompass everything into one line, that people get lost, right? I don't know if you agree with that. Oh yes. And you can correct me anytime you want. I don't mind. I don't have any ego. Almost. My ego does fit through the door. All right. So where was I? And last time I coded Arduino code was well before the pandemic. At least, so it's at least 5 years ago. The only thing that kept me sane in programming wise is assembly, but I forgot my semicolon here. I don't think I made a mistake here. Let me know if I made a mistake, by the way. My job is writing firmware running in X-ray machine. Oh, X-ray machines. And you use AVRs, really? That's interesting. All right, so, well, that would be it, right, for the right data bus. I loop 8 times, grab so I should be fine with this, right? If I want to grab each bit of the value, that should be fine. I think so. Well, we'll know soon enough. Oh, in the setup though, and let's do the setup. I have to set it as output, right? Pin mode. Let's do the address also, just in case. Just in case something goes airy. Airy? Ari. No, not Harry. Just in case something goes wrong. There. Said it. You know what the definition of synonym is, right? It was when you can't spell the the word you wanted to use in the first place. All right, so for uint 8, I equals 0 semicolon. I could switch to French if people want me to. I is smaller than 16. I plus plus. I plus plus. I should start goofing off. And then pin mode. Pin address. I, not 1, I, comma, input, semicolon. Right? Should be right. Should be right. And because I'm lazy, copy, paste, 8, pin data as output. There. Thank God for laziness and copy paste. Save. So let's do a quick compile, see if I have any major issues. That looks good. No errors. No. Doesn't mean I don't have any logical errors, but so it looks like it should work fine. Okay, cool. I would not understand a single word if you switch to French, as I would not understand anything if you switch to Norwegian. I'm pretty sure. All right, where was I? Now, I need to also declare the clock, the pin, the LED, and the E. Let's put the LED in on top. It's not the same. Okay, pin LED, the clock, and the E clock. Just so you know, there when you do for the 6309 and the 6809, your clock that you input, the crystal that you use or the oscillator, has to be 4 times as fast as what the CPU runs at. That's because for some reason, and I have to read on it why they do it like that, is they need to build a quadrature clock. So basically, they start with the Q clock, which goes is asserted 90 degree in front of the E clock. Then 90 degrees later, you have your E clock going up. And 4 cycles later, Q goes down. Is it 4? No, 2. Well, anyways, I should do a schematic. And then E goes down afterwards. Then you have low, and it goes back up. And it's kind of weird, but I know that the address, the valid memory address, is valid at the rise of Q, and the data is at E. And there's a few other things also, which they require certain combinations. Some, and I believe at the fall of Q, there's something else going on. So it's not as simple as the Z80 or the 6502. 6502 is even simpler. All right. So now let's go back to the business. Let's 13. So the LED, the clock, and pin E. Let's declare them in the setup. I should be commenting my code, but if I start doing that, already we've wasted quite a lot of time. So pin mode, we need to declare pin mode for pin E as input. But as you said, I don't really need to since it's an input. I guess you need to declare it at least once, because if your old code that you overwrite is an output, shouldn't that be a problem? Question for you. If you're the code you had before, and let's say the pin number 3 was an output, and then you upload a new code into the flash, and now it's an input, or when you upload anything, that do all pins automatically become inputs? Good question. Let me know if you have an answer for that. Asking for a friend. Pin mode, then pin mode for clock, which will be an output. Right. And there's another output, which is the pin LED. Pin LED. No, pin mode. I'm distracted. Pin LED. Maybe I shouldn't have named it pin something. is output. Right. Okay. Now we've got to at least say that we're starting the clock low. We're starting low. So digital right. Pin clock low. I guess I could say also that since we don't need to declare it in the main, in the loop one, we guess we could do right after the data. We could also say, let's drive data bus, right? The function that I used. Write data bus. Write data bus 0x12. Or is it $12? I think, yeah, it's 0x, I think. There. So that's done. What else do I need to do? So we got our serial. The pin mode of the LED should be off. So digital write. Digital write of the pin LED. Should be low for starters. Okay. All right, let me see if there's any comments. AVRs, all pins to okay, at reset, they all become inputs. Okay, good to know. Oh, it does autosave. Thank you. I'm paranoid with saves. Number of times I lost my work. Write quite a bit about AVR, reset states, and bootloader programming as the X-ray machines support remote firmware updates over CAN bus, which we use for interboard communication. So you use CAN bus within the same machine? Is it because of interference? Because of the robustness of the CAN bus? Okay, 0x. 0x is 4 hex. Good, thank you. Thanks for sticking around. Hey, François! Comment ça va? All right, where was I? Yeah, François, for a quick recap, I'm building a pseudo logic analyzer for my 6309 computer. So right now I'm doing a NOP test machine to see if virtually I can, trick the CPU into giving me the data, and if it works perfectly, which I think it will, then I'll be able to test the PLDs that I'm going to be programming for the next episode, because there's no way for me to test the PLDs without wiring everything together, and then if something's wrong, I just won't know where to start. So I'll be able to start testing the PLDs. That's what I'm doing basically. So I'm building a virtual NOP tester, no operation tester. CAN bus is pretty fault tolerant, and we have many different boards in the machine. Yeah. Is it, I forget, is CAN bus, it goes parallel? Is it parallel, or it just goes, it's not tokenized, right? It's like whoever's address is selected, they read and just send out the data that's being requested, I think. Yep, to simulate bus cycles. Yes. I'm going to generate the clock, and I'm going to wait and read what I'm going to send out the hex 12, which is the no operation opcode for the 63 and 6809. And I'm going to read the address bus, and it should be counting in binary if everything's doing what it's supposed to do. Alrighty, now let us look at what else I need to do. So I've got my right data bus. It's perfect. I don't know why I did it this way, because I know I'm doing 12. I did not need to pass it as a value, but it could be used for eventually something else when I reuse the code for my PLD testing. Don't need to do a save, but I did it anyways. CAN bus is a differential serial broadcast bus. Each recipient is responsible for checking if the message is for itself. Ah, okay. Good. I guess it's a lot better than what was it? 420 4/20 milliamp communication, or the RS-45. Where was I? That's it. My brain is starting to not to function. Okay, let's start from scratch. I need to write, let's go here. I don't remember why I wrote this, but I need to start. If I want to generate my clock, and let's say I want to do it every 100 millisecond. Well, I guess I could just simply go. That's the stupid version, instead of using a timer, because I could use a timer, but I have to read up on it. I haven't used a timer for a while. I guess I could start with the clock. What was the pin again? Pin clock, right? Pin clock. Digital. Right. Pin clock. Since we started at high, we start at low, we go high. So if it's high, oh wait, I'm sending the clock to the 6309. It will do its thing until it will do its thing. So it's going to activate the Q and E clock. So basically, either I wait for the E clock and read the address bus, or I use an interrupt. Now, if I recall using an interrupt, I'll go back to this portion here. Something interrupt. I want to do something interrupt. I have to do this before my routines. Attach interrupt. Yeah, attach interrupt. I love this autofill. Interrupt number. That will be my pin, right? And I believe I put pin E, and 2 and 3 are interrupt pins. That's why I put it there. So pin E. Then I have to give it up to a routine, right? Function. Okay. On rising E. On rising E. Right? Do I need to put a value? Is it always void? It says void, right? It's void, return value, and void value, input value. Yeah, I'll obey what it says. On rising E, the mode. Okay, let's look up the modes for attach interrupt. Attach interrupt Arduino. Low, change, rising, falling. So I need rising. I am learning as we go, as you can see. And let me see if I have anybody screaming, "No, do it that way, you dumbass." Thank you, rising. I should have watched the chats first. Don't you have to call a function to get this from the pin number? Well, yes, I have to create the function. I hate autofill. Well, I love it when it's been 5 years since I've coded an Arduino, right? It helps me remember things. But if you've done it 2 days ago, it's like I hate autofill and I hate autofill in assembly also. Because, I'm more used to assembly than I am with high-level languages for the last 4 or 5 years. Where is it? Rising. You spelled it? Yeah, rising. Oh, there, rising. So on e-rising, so I need to create a function for that. Void on e-rising void, right? That's how you do it. I hate autofill because I have written Arduino code almost daily for the last 10 years. Yes, it's like autocorrect on the phone. It's annoying as hell. Or any Android phone. Now, in theory, what I want to do, that's the theory of the theory, would be to if I need, I don't know, let me look it up. Do I need to put void in there? I don't need to put void. Yeah, I guess it doesn't hurt. Let me know. Do I need to put void in there? I don't recall. I don't recall if it was necessary or not. So, I've got a 16-bit address. I can't be an interrupt. So I need to read the address bus. I have the function for it. Unsigned integer 16. Address. I haven't declared it global, so I can use it. I can use the same one. Address equals. There it is. Read address bus. Read address bus. There. And then address to what I need is to put the address where I need to put it in a global variable if I want the loop function to read it, right? Okay. So basically, address can be global, but I already used address here. So I can't use it here, but then I could use anything. I can use any letter. Like, so it just doesn't, no, I can change it to global address, right? Yes. But I have to declare it first as a global address somewhere else, do I? Yeah, I have to declare it somewhere else, outside of a function. Control C, and let's put our... Normally, I think you have to declare it outside, right? And I guess we could put it at default 0. Doesn't if it matters or not. I think. Yeah. Global address. And so we don't confuse, let's just give it a name. A. So we don't mix it with the global address, but this is already declared, so we can delete that. So I read the address and the address bus. Do you think that's enough? Do I need to do something else with that? Yeah, let me see let's see who's yelling. It has to be declared as a volatile global to be able to access it from loop. Volatile. Can you tell me more about volatile? You don't need void in there, but it doesn't hurt either. Okay. Well, it looks weird. Looks better that way. Yeah, you need to call a digit pin to interrupt for the first argument. Digit pin, can you elaborate on that? Digital pin to interrupt. Yeah. Can you, François, peux-tu être plus... donne-moi plus de détails là-dessus. You don't need to void bloody Firefox skipping keys. Then you can make it global. Might want to make it volatile. B-access would be volatile. So what? Is there like a volatile keyword for that? Yeah, apparently. Okay, volatile. Is there like volatile? Why? Explain what volatile does. Attach interrupt digital pin, interrupt pin, ISR more record min. Okay, digital pin. That isn't that what I did? Yeah, pin E is my digital pin. And then ISR mode. Yeah, that would be my interrupt service routine is this one. Attach interrupt pin, ISR not recommended. Additionally, this syntax only works on Arduino SMD boards. Wi-Fi. Okay. Volatile tells the compiler to always. I'm reading a bit everywhere. Make sure the compiler doesn't optimize it out. Doesn't know if ISR might want to. Okay. Because the compiler doesn't know it's an ISR and might want to optimize it anyway. Really? As per the official docs, you should use digital pin to interrupt instead of just pin. Digital pin to interrupt. So basically, instead here, you mean? So I should put digital pin to interrupt. Pin E, is that what you're saying? What's so special about that, though? What does the doc say? Okay. So what does it say? Using interrupts. Okay, recommended. Interrupt. Yeah, please interrupt. Low digital SR. Yeah, they do use it that way there too. Huh. Okay. You want to ensure that a program always caught the pulses from a rotary encoder so that it never misses a pulse. It would make very tricky to write a program to do anything else because the program could need to constantly pull the sensor lines for the encoder. Okay. And this. So if I go okay, it shows up in Arduino sketches. Here's the deal. What it does is a helper macro that converts a regular Arduino digital pin number like 2 and 3, etc. into the corresponding interrupt number used internally by attach interrupt. This sets up the interrupt on pin 2, calling my ISR whenever the pin goes from low to high or whatever. Why not just use 0 or 1 directly? Back in early Arduino days, you had to remember which interrupt number match which pin, for example, blah, blah, blah. Okay, so, okay. All right, analogy. Think of it like using someone's name instead of their phone extension. Call Bob is cleared and dial 3471. Short version, use the digital pin to interrupt. Whenever you call, attach, interrupt, it saves your sanity, makes your code portable, and keeps you from having to memorize weird board-specific mappings. Do you want... Okay. All right. So I get it. I get it. Hello again, Trina. Pin number that made the number pin as a part register, while the interrupt number is a number of interrupt triggered by this pin, which can be different from the hardware base. Yeah. Okay. Well, like it said, it's all right. I get it. Thank you very much. It is very helpful. I would have had probably certain issues. What would have happened if I kept it as is? Also, attach interrupt should be in the setup or loop. Oh, okay. So this thing here should be in the setup. Get rid of that. And setup. Thank you. That will save me a lot of time trying to figure out what the hell's going on. Guess I could put it here. There. All right. Just for sanity's sake, let's do a compile, see what happens. What did I do wrong? G address. Read address bus. What did I do? Compilation error. Oh, I forgot some sort of semicolon. No. Shouldn't be a semicolon there. On rising there. G address there. No, yeah, that's not supposed to be there. Tune there. Compile. Still an error here. What's the problem with this one? Forgot the semicolon. Compile. There. Okay. Stupid errors. Check. All right. What else? Good. Perfect. Now, time to do some serious coding because I've not been serious. That's not true. I'm always serious. I'm so serious, I'm boring. All right. Now that's done. Now the E. Now the interrupt. What do we do with that? What do we do with that one? I need to on rising E. So I got the address, right? And I put it in G address, the global address. Thank you so much, by the way, for helping me out. It is very appreciated. That's it. I just need to get the address. The only thing is, I need to tell the loop when to print it, right? Because how do I know when there was a when the E rises high, I get the address, but I don't want to print on an interrupt, right? Because we don't want to waste time in an interrupt. In theory, I guess we could. It's not going fast enough. I could print from here, and loop would have almost nothing. In theory, right? All right. Well, what do you think? Let me check. Let me check what you guys are saying. So now for volatile, the compiler would think you're reading G address without setting it, because on rising E is never called by another function, only by ASM stuff, which is which the compiler doesn't know about. So it will instead optimize as a 0 without actually reading at the address of the variable. No serial and ISRs. Oh, okay. So I should never use any serial print. Okay, thank you. That's why. I thought so, but I guess it's good practice not to do it. You don't want to waste time in ISR. So I'll leave it at that. So I'm trying to understand what do you mean by François. So it will just instead optimize as 0. For now, volatile compiler could think you're reading G address without setting it. So I've put volatile unsigned interrupt 16 G address equals 0. When it first sets, it's at 0. Then I'm reading the address bus, and the address bus, as we can see below, returns an unsigned 16-bit interrupt, non-interrupt, sorry, integer. So what is it you're trying to say, François, about that? I would think, though, that here I should set a flag. Volatile forces the compiler to use the actual variable value instead of optimizing it in any way. So the way it's set up right now, it's okay, right? Because I'm forcing it to be in a particular type, I would think. Okay, here I want to set a flag so I don't overprint. So I don't print twice or 3 times the same value. So let's create another. What's the difference between volatile and static in this particular case? Volatile. I want just a flag, so it's going to be it's going to be a Boolean, right? Volatile Boolean gprint g global. What do we call it? Print pending equal false, and here we shall put then it becomes true. G print pending equal true. Right? So I know there's something to print because G address, there's no way to know when it changes unless I start making a copy of itself and comparing it each time. That would be another way to do it, I guess. Let's check the comments. You need some semaphores or other synchronization mechanism to tell the code outside the ISR that things changed. So basically, setting a flag would be one of them, right? like I'm doing right here. So all I have to do in the loop basically is, let's get rid of this for now. Basically what I need to do is yeah, the flag approach is better than comparing with old values. Thank you. I thought so. Thank you for confirming that. Great minds think alike. Yours and Arduino is much better than mine, though. You and François. All right. So now that where am I at now? So so basically, I'll do the clock later. I'm just going to do the logic for printing. Just going to get rid of that for now. It's distracting. So if, reminds me of the silly jokes I hear on the internet. If a dumpling, no, what was it? If we call a dumpling, no, what was it? Now I have to find it because I'm going to mess it up. If we call the food dumpling, is there one that's called smartpling? All right. If gprint pending is equal, wait a minute, not equal. It's a comparison, so there's two equals. True. If it is true, then I recall that, like an assembler, I have to deactivate interrupts when that happens, right? Assembly is the same thing. If I'm dealing with if I go into an interrupt vector, I have to deactivate the interrupt flag so it doesn't get interrupted. Interrupt. So there is something interrupts. What's the inverse of, is it no interrupt? I think, yeah, no interrupt. No interrupts, and then we want to go and interrupt again, and anything between that is safe from being interrupted. Now, gprint pending equals false, so it doesn't print it again. The thing is, do I print before or after reactivating interrupts? Now, in this particular case, we're going slow enough that I don't think it matters, but as a good practice, if we reactivate the interrupts before printing, what would happen if it's going too fast and you get so many addresses coming in, so many e-clock, you're going to the ISR so many times before I have time to print, and you're missing some prints, right? Am I reasoning correctly? So I would have to do the clock so it doesn't do that. But we're never going to go faster than what the serial at 115, 200 If I do it 1 every 10, every 100 hertz, I don't think 100 hertz would hurt anything. So it could be before or after. It doesn't really matter. So let's see what you have to say. All right. The true part is not needed because it's implicit, right? Yeah, you're right. Because if you're saying it, it's if, then it's going to evaluate the true first. If there's an else, it would be false. That's true. It's a great optimization. The compiler doesn't code calling your rising E will assume G address is never set. Wait. I missed something. The compiler doesn't see any code calling on rising E, so it will assume G address is never set. So it's always 0 unless you set it as volatile as such. Okay, so it is volatile, so I'm okay. Not sure if you saw it earlier, but why micro and not millis? Yes, that's why I erased it, because I'm not sure yet. And you're right, it's better millis, because I'm never going to go fast enough. The true part is not needed. Perfect, so I removed it. Comparing values that are larger than the transfer size is not atomic anyway on these microcontrollers, so you need to read it. You need to read twice. Comparing the values that are larger than the transfer size is not atomic any on these microcontrollers, so you need to read twice. I mean, the fact that larger values will take more time, is that it? Serial print needs interrupts to be active. Serial print needs interrupts to be active. Really? And yeah, if you disable interrupts, then it should be safe to read. Why does serial print need interrupts to be active? If you toggle the clock manually, you can just hold it until you've printed. Yeah, that's true. Indeed. Yeah, that's true. So let's handle the print. So you say, Rinky Dink, that interrupt needs to be active. Serial I/O is interrupt driven. Ah, yeah. Well, that makes sense then. That makes total sense since it's the case. We shall then print. We shall print the address. So now that I do a for int for unsigned int 8t I again, bit, let's call it bit, let's call it I. For I equals, wait a minute, do I start at 0? Because I want to print the MSB first. I want to go totally to the end. So it's got to be 15, not 0 this time. Am I wrong? Bit. No, I said bit, but it's I. Do it until it's got to include 0, so greater or equal to 0. Give us some spacing. I like the spacing a bit. It's clearer. And then I minus, right? Then I open the bracket. And then yeah, I have to go grab the address. How do I do that? It's a global variable. I can. So if I hope I won't be as slow when I start recoding assembly, because it's been a year and a half since I coded assembly also. If address, if global address, is that how I spelled it? Yes, address. Got the address, and I want to end it with the 15th bit. I'm going this way though. So is it and no, I'm going the wrong direction. If one unsigned, so there's no confusion, is, you know what's going to be awful about this is I'm gonna have to retype everything, so I simulate that I'm typing like Ben Eater does, and re-edit it with a VO on top of it. I'm not going to use this because I'm publishing at 720p anyways, and I'm going to be publishing at 1440p. Yes, new and improved video. I think that's it, right? Yeah? 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 Yes? Maybe? Why do I have a feeling something's missing? I got the address. I'm ending it with one here, right? So I've got one, everything is zeroed out. Great. Now what? Okay, let's try that. Then serial print. One. Else. No, else there. Looks cleaner. Else, serial print 0. Right. And then after that, after that, so it should be right after this one, after the 4. So this one here should be Sol print ln, serial print ln line. Right. I've got my doubts for this one. Let's see the comments. Okay, what did I missed a few things. Yes, probably the serial port generates an IRQ when the FIFO needs filling. Missing a semicolon after the false. You're right. Thank you. Just copy G address to a local variable, then you can release IRQs. Well, G address is already out of the... Oh, wait a minute. Just copy G address to a local variable, then you can release IRQs. Why? Because there could be an interrupt that uses G address as I'm using G address. I guess that's what you're saying. Makes sense. So let's call it, I don't know, a local address equals G address. And then I just call it local. Let's call it L address. Like, otherwise I'd have to name everything global instead of G. Looks like a 1. I don't like it. Let's call it let's call it ADDR. Simple. There. ADDR. There. Okay, what else did I miss? Also, code will be more optimized than reading from a volatile in the loop. Okay. Why is that? Now, after that, G address. Okay, there it is. So G address. Well, I've changed it to address, but it's what it used to be. Ampersand 1. So I don't need the U. I just thought that U would be, well, it doesn't really matter, does it? And then I close. You want to print as binary? Yes, I want to print as binary. Shifting is slow. I'll try to avoid shifting I times. All right. So unsigned interrupt 16T A equals G address. Yeah, okay, so I used address instead of A. That's fine. Then the 4, I would have used sprintf option. Much cleaner. Okay, I'm not too used to using sprintf. Serial print A ampersand 0x8000 point question mark 10 A equals A shifting 1. Yes, the ISR could be writing one of the bytes of G address while you're reading the other. Okay, yes, perfect. Last call. Let's call it AAA. Your code should work as well, maybe a bit slower. Okay, so what you're saying is, I'm curious, François, about your serial print statement. trying to make sense of it. So if A, which is at ADDR now, and the first 0x8000 shifting is slow, so just shift it by 1 each time instead of shifting 15, 14, 13. Okay. So how would you go about doing it? You just check the upper bit for A, then you shift the next bit into MSB each time. But yeah, this code should work too. So is that what you're trying to do with the serial print statement? Just try your code, it should work. Okay. All right, let's try that. And if not, I'm curious though about your serial print statement that you put up there. Okay. Where was I? Right. Now about the clock. Now that that's done, we know that we captured the address at rising E. And if there's a print pending in the loop, it will print it. I just need to do the clock. Speed isn't much of an issue in this case, so the current code should work just fine. Okay. Clock. Clock. So I could do I guess I could be very lazy and do a digital write high, wait like 500 milliseconds, do a low, wait 500 milliseconds, loop, but within the loop of the high, then I read the print pending. That would be the lazy way of doing it, and in this case, it would work. Or I set an automatic timer to do the clock, right? To sort of PWM it. I guess I could do that. PWM. Because I don't need to control the clock. I just needed to provide a clock. I can software control it if I wanted to in the future. All right, so what are the minimums and the maximum of PWM? And do I have the right digital write, analog write? I think is that it. We'll do a PWM. I don't remember analog write. Analog write. Analog, yeah, there it is. Analog write. Writes an analog value, PWM value, wave, to a pin, can be used to light an LED, brightness, blah, blah, blah. What are the minimums and maximum I can go to? Value, duty cycle. It's just a duty cycle. 0 to 255 to always on. So it's a duty cycle. It's not a frequency. So I would guess that the PWM could be programmed with a timer, if I recall. Am I right? So depending on the frequency of the timer, it might not be what I want. The PWM outputs generated on pin 5 and 6 may have higher than expected duty cycles. This is because interactions with millisecond delay functions which share the same internal timer used to generate those PWM outputs. This will be noticed mostly on low duty cycles settings from 0 to 10. See also analog write resolution, PWM, and blink. Okay, it's function defaults to 8 bits, values, backward compatibility, syntax, parameters, returns nothing. That doesn't help. Blink, PWM. Right. Yeah, it's only the duty cycle. It has nothing to do with the frequency. So basically, okay, let me check the chat. I'm trying to research it, but all right. What did I miss? What did I miss? Let's call it A. Maybe slower. Shifting is slow. Must be check the upper bit. Yeah, to try your code should work. Yes, okay, I've seen that. Speed isn't much of an issue. 0, it will be true if MSB is set. Yeah, so 15, I'd say for testing, no need for a timer. Make sure it works first. Unless there's a minimal clock frequency. No, there's no minimal clock frequency. Messing with PWM timing can get very ugly very quickly. Okay, because it is linked to timers, right? So, and if you change the timer, I suppose if you change the timer prescalers, then you mess up other things, I presume. You said duty. On Arduino, PWM API is by default like 500 Hz or so. Yeah, okay. Trina's technical babble. I've done my duty for queen and country. You can bypass the Arduino API, but it's board specific and you need to set registers manually. Check the minimal clock frequency for your chip. Then, I once wrote some code giving me a 1 to 1000 Hertz output with any duty cycle from 0 to 100%. It was a nightmare to get it right. Yeah, PWM doesn't change the frequency, just the duty cycle. Not all pins run at the same frequency, though. Really? They don't all run at the same frequency. I guess some of them are tied to specific timers. All right, so let's do it the good old-fashioned way. And by wasting a lot of time. So Yeah, Millis uses one of the timers, so if you change it, you mess up timing. Yeah. And there aren't that many timers on it, so you don't mess with the wrong one. And I'm sure they're all being used for something, unless there's one that's like free for all. I guess. All right, so we will. Whoops. We shall be doing. What was it? Pin clock out? What did I name it? Yeah, pin clock. Pin clock. Digital. Right. Pin clock. Hi. Hi there. So as it's high, it will check to see if there's a pending. Wait a minute. I may be doing something wrong. Because if it's high, well, no. The E clock is 90-degree delayed compared to the Q clock, and I'm reading the E clock, so it doesn't matter if I start right away the clock at high. Oh, honest question. Why do you not have at least 2 monitors connected to this computer? Actually, I have 3. I have the one that's right beside there, which is my prompter. It's got a monitor. You can see part of the stuff going on here, like my mouse there. There's a part of the screen right here, but it's reversed, so I can't do anything with that, right? And there's no screen over there. That's when I'm sitting over there. I can have a reference of some kind, and I've got a mouse and keyboard, which is also on the same computer, and I can type and do stuff. But my card does support a 4th screen, which I might put right here. So I'll go grab another screen from downstairs and get myself some sort of mount and put it there. Okay. So yeah. Is the question answered? The Mega 2560 Arduino Mega has 6 timers. Oh, good. I guess some of them are used for users can use without screwing up things, I suppose. Yep, not all pins are the same timer source. Yep, Millis is one of the timers, so you can change it without messing. Okay, all right. So now, where was I with all of this? Yeah, so I was in the loop. I am putting the clock high. And I don't want to do a delay because then I won't be able to go and print. So I have to go and grab the Millis value somewhere, then compare it to compare the past and current Millis to see if 500 milliseconds have passed. Let's say I want to do it every half a second or a tenth of a second. How can I live without 3 screens? Yeah, no, I need 4. It's a necessity for life. Okay, so before I start this, um, do I have? I remember doing a lot of that. Checking out. I have done it before. Now let's see if I can remember it. Now, if I have a Geelong, right? So it's int 32, right? Int 32. Start. Start my millisecond equals millis. So I start a millisecond timer. Then I write the clock high. Now I want this to execute sometime in there. So it's going to be part of a loop, right? So then I have to check. Do I do a... It's getting late. I'm starting to have brain fog. So I do while or while do. How does it work? I forget the do whiles though. Is it do? Do statement while or while condition. While will. How do you end a while though? While this condition do that or do. No. Okay. Gotta check. Always fun writing non-blocking code. Now imagine doing that with 250,000 lines of code. Yeah, but you're used to it. I haven't coded Arduino for 5 years. I'm gonna check my old code. I remember when I did the UVC clean box, I used a timer, a comparative millis timer. Do I still have that in the computer or I stored it somewhere else? Phi Electronics, Phi Projects, Shield, Test, Brand Fan, Arduino, Brand Fan. Let me see if there's anything in there. I'm going to reference old code because I'm sort of a bit confused. Oh my god, that's terrible. All right, come in speed, map, random, update LED timer. Sorry, you're not seeing what I'm doing right now. I just don't. It's boring code. Oh no, I did a quit and it quit all windows. Let's put IDE. Will it come back? Am I okay now? All right, yeah, so I'm back and ready to rumble. So I want to quit, to close it and not quit, because it's a second window. And yeah, there, close and not quit. Okay, so not that one. Do I have the one for the Uno Shield socket? No, that's something else. No, that's something else. File electronics. So I don't have it here. Others projects. No. MicroHobbyist. Picture backup software and drivers. UVC clean station. Yeah, I'm sure I have something in there. That would be Arduino Mega 1. Version 2, it was Uno. Let's try Mega 1. Yeah, back in the day during COVID, I did UVC clean box for virtual reality headsets and backpacks. It was a huge box. There was these huge neons, 4 feet, all around in a box. You put the device in there, press a button, and 20 seconds would have been enough, but I put it 2 minutes. It just blasts. I mean, it just it's off the scale, the UV value. I bought this UV meter, and I've read the requirements from the CDC and hospitals, what they do, and the values. I don't remember the exact value by heart, but it needed a certain amount of UV to kill anything, right? Any sort of germ, microbes, viruses, whatever. And basically, I did 10 times, above 10 times what was required to kill any germs, viruses, and whatnot. So, yeah, so it was a pretty clean and safe thing to do. All right, I'm still looking at the code here, see if I can find a reference to these for a timer, a comparative timer, so I'm not wasting time trying to figure it out again. So if I go to that's the uptime, my God, it's big code. I didn't realize it. Okay, there it is. All right, so if millis minus previous temp red is greater than the number I want. Okay. All right, so I'll use this. I'll be lazy and I'll cut and paste it. Did I do something else with that? Okay, so basically, let's go back here. What's this? Restart. Setting has changed. That requires a restart to take effect. Cancel. I don't want to restart right now. Here I am. So I got, we'll call it previous milliseconds. Previous millis. There. Shorter. Let's see. Let's check the chat. I haven't checked the chat for a while. Always fun writing. Okay, multi-threaded code. That's demanding. Imagine writing code for BOS. Well, no, I don't want to imagine that and have a headache. Well, do is the do is implicit there. I use some limited multi-threading when I write C# applications for Windows. Autosave to the rescue, and you can you can see a dot behind the file name in the tab when you type. When the dot is gone, it is saved. Oh, okay. Ah, I see it. Yeah. Okay. I saw the dot. Thank you, Rinky Dink. All right. So where was I? I want to read Millis, right? And then, sorry, this is boring right now. I'm trying to figure out how I'm going to do things. So if I read a previous Millis, now I want to compare it. Now I want to be in the loop. And the loop will be, the condition will be if I reach, let's say, 100 millisecond, then get out of the loop. Okay, so do this thing. So grab everything and shift everything. I'm sure there's a way to re-indent everything. I think there's a way, right? I don't need to do this because I think there's a re-indent function somewhere. Where is it? Auto format. Okay. Well, next time I'll know. All right. Do while. Is there an until? No. It would have been funny if there's an until. Do while. So the Millis minus previous Millis is smaller than 100 milliseconds. Oh, wait a minute. How does it show Millis? Millis, it's shown in milliseconds, right? 1 would be 0, but 1 would be the smallest for 1 milliseconds. So then smaller than 100, so that would be 100 milliseconds. Do while that, right? If it reaches 100 milliseconds, I have. Oh yeah, I just want to make sure. 2 millisecond. Do print that forgot to put it high. Or maybe I should put it before. Just for okay, go high. Then right now I'm starting the timer at, it's called previous milliseconds. And do check if the print is pending. If it is, then print it. If it's not, then exit. And do that while milliseconds, which is the greater number, minus the smaller number, is smaller than 100. I think I need a semicolon here, right? Okay. Then after that, I do Control C, Control V. I do a low. Then I can do a delay and waste my... Oh, what did I do? High, not high. Really? It has to be caps? Well, it says so here, so I guess you're right. High, so it means low. It should be also... And did I do the same with other... Low is okay. It's high input, capital. Did I miss? It's capital. Okay, the rest is all capital. Thank you. Well, define until condition while condition. Well, hashtag define until condition while condition. Okay. Yeah, I could define a variable called until is what you're saying. That's true. Define begin. Aren't those reserved words? And? No, and is not defined as a reserved word. Begin. No, neither begin. Huh, yeah, I guess you could. Learning a lot with you guys. Thank you. Oh, Pascal. Oh my God, I've done Pascal when I was in school in 1988. That dates me. Pascal. I don't remember if I liked it or not. I really don't. Do people still make Pascal compilers nowadays? All right, so now I do the low and the low, but this time I just need to do a delay. And is delay in milliseconds? Yeah, delay long milliseconds, 100. There we go. And then then it loops, right? Loops back. It's low for 100 milliseconds. Goes back, goes high, right? Pin clock, goes high. Then I start a timer. I do while milliseconds is under 100 milliseconds. I loop into that. It's not. I don't think it's elegant code, but it works for the speed I'm running at. And also it's perfect because I want to do it simple so that people can follow along if they dare. Wasn't it Turbo Pascal is Borland, right? Let's see. Compile. Do I have an error? Whoops. Yep. What's wrong? Expected. Couple of errors. Okay. Function void loop error address was not declared. Yeah, I didn't declare address. Dumbass. U int 16. Okay. Compile. And did I miss something? While compilation error expected while at the end of input. I remember I purchased Borland C++ back in the day. That was after I finished, I've graduated school in electronics. And I was getting married. So I never opened the package. It was still, well, no, I opened it, but I've never used it. Number of times I bought stuff. Okay, why am I getting this error? Expected while at the end of input. I think the curly brackets is an error with the curly brackets. Is there an error somewhere else? Just want to check. No, it's really at the end. So am I missing something? This is going to here is, do I have my closing bracket for that one? So do open. Did I close it? Is that for the do? That's for the if. So I didn't close it. Compile. Great. No errors. And it's only like 84 lines. I was expecting it to be bigger than that. Okay, let's try it on the Arduino. Is it plugged in? Yeah, it's plugged in. Program it. All right. Thank you. Let's check the serial monitor. Yeah, I think I forgot a... No, println is there. And I'm just printing zeros. And printing zeros, and it's not doing the serial println. Well, first of all, let's resolve the println issue. Why isn't it changing line? Put it a separate line. Better readability, in my opinion. Yeah, I think you're right. When you look at stuff like this, and you do like this, yeah, I think you're right. Look, you save a line, but readability, the readability is actually improved. Let's do that. Guess people do that just to save some lines, so it's neater, I guess. Much easier to see the different blocks that way. Yeah, I agree. Right. So why does serial print? I did do it properly, right? Serial dot println. And well, I don't see the reason why that doesn't work. Now, it always prints 0. That means something's wrong with my condition here. So theoretically, theoretically, why would the println if it prints 0 all the time, the condition is wrong. So the address ended with 1. Well, I had 1U earlier. Would that change anything? And then bit shifted to I. If it's not equal to 0, I'm not doing a comparison here. I have to do a comparison. I'm just doing an action without comparing. So either I do, is it equal to 1, then if it's equal to 1, is it 1? I think the U is useless. I think that's what it stands for, not unsigned, but useless in this case. Let's take it away. If it doesn't work, I'll put it back. Compile. And I want to know why the println didn't work. Here at the end of 4, 16 times, this one here goes to here, then I serial print. There, it should serial print regardless. Oh yeah, let's try it. Compiling sketch. It's taking its diddly time. Why? What did I do wrong? Much easier to see the difference. Make sure you can print something before doing anything else. Well, I printed zeros. Equals 1U will not work. You have no use. You have to use not 0. Really? Why? Isn't it the same thing if compare it to 1 or compare it to not 0? It's binary. It's Boolean. Is it? Oh. No, it's not. It's not Boolean. I'm taking you're bit masking. The result will be true if the selected bit is 1. Okay, so if I mask 8,000 and 8,000, which is not 1. Well, you're right. So it's not 0. Okay. I would have thought otherwise. Well, in appearance, it looked logical, but I'm not actually working with a Boolean here. So now it makes sense that it's not 0. Am I thinking correctly in saying that? Message, enter Arduino Mega on COM4, blah, blah, blah. Compile. What's it doing? Compiling sketch. It's has a problem. So let's get rid of the monitor. Okay, let's compile again. All right, good. Now let's send it to the Arduino and look at this. All right, so at least now I'm seeing zeros and ones, but I'm not seeing a binary count. It's either all ones or all zeros, and it's not changing lines. Not changing. Yep. It's numeric, not a Boolean. Yeah. Okay. Thank you for confirming. Okay. I don't get it why this one, serial print ln, does not change the freaking line. The bitwise and ands each bit separately. Yeah. Isn't it what I did? That's a bitwise operator. I'd like to fix the serial print first, the print ln. It's print ln, right? Well, I don't have. Let's get rid of the serial monitor. It's getting annoying. Serial dot print ln. It is print. I did not do an error. And do I need to give it a dummy value? Okay. Nope. That doesn't change anything. Okay, guys, why is my print ln, which is the most basic stuff, does not work? Print ln should work without any parameters. Yes, I agree. And there's no, I don't see what the issue is. See, I start my loop, right? I can get rid of this. It's like, that's useless. I write high, previous millis, do, unless I made a mistake with my curly brackets, if print pending, then we print Then go down. There's no stray curly brackets. It ends there. Yep, that's why the result is not just 0 or 1. You can call serial println, but it should be the same. Yeah. Why the hell is it giving me this? And this one is associated with the do. Okay. And here, well, I'll go check if it the clock works, right? Hold on a second. No, the clock is not working. I use my logic probe and it's flat. It is flat. So it's just digital right, pin clock high. Right. There's no error there. Digital right clock high, pin clock high. And I go digital right, pin clock low. Delay 100. Now, delay, is it really 100 that I have to put? Delay. Delay. Display, string, sensor, communication, analog, digital. Why am I not? I'm doing delay. Why am I not seeing in the doc delay? Help. Reference. Delay. Blink without delay. No. One wire protocol. Accessing accelerometer. Accessing. No. In language reference. Oh, there it is. Delay. So, delay in milliseconds. Delay 1000. So I can put 100. So yeah, there's no problem there. So there is no issue with the delay. So that means it's stuck in the while loop. It's not, but it's printing. So it's printing crap. It's printing crap ad vitam. If it's printing, that means it's entering the print pending. And print pending equals false. Then prints. Does not serial print. It should, right? Okay, let's comment out this thing and let's see what's going on. From there to there. All right. And all we'll do is serial print ln hello world semicolon delay 100 semicolon. So that's it. Oh, we can ignore these ones. That's fine. Doesn't matter. Just to see if it prints. Right? Okay. Yeah, so I'm printing hello world every 100 milliseconds. So that works. Good. Okay, yep. You can call serial println. Looks to me like it gets stuck in the loop for some reason. Yeah. Oh wait. And it is always greater than 0. What? Oh wait, a unsigned interrupt is always 0, greater than 0, unsigned. Really? In the 4. Yeah, that sounds like the reason change 8 to int. Really? So it should not be unsigned? Really? Huh. Okay, let's get rid of those. Let's get rid of the comments. Go back there. So you're saying that it should not be an unsigned here. Didn't I use unsigned for for loops before? Okay, what's the reason you've written somewhere? Wait. An unsigned int is always greater than 0. Greater or equal than 0. Why would it matter if it's declared unsigned, though? Good thing to read the chat frequently. Yeah, it should, huh? Change here to for the statement and good thing to. Yeah, I will read it more often. Uh, 0 to 1 for 0 to 1 for an unsigned int. 2 to 55, which is greater or equal than 0. So endless loop. Wait a minute. I'm trying to wrap my head around that. 0 minus 1 for an unsigned integer 8-bit is equal to 255, which is greater. Oh. Okay, I get it. Yeah, okay. That makes sense. And this is the problem. All right. Okay, that's a good catch. I really did not think about that. And
and I didn't have, and the reason why the other 4s are unsigned, they don't go in that direction, and I'm not measuring. Yeah, they're all going on one side, and the positive side, never the reverse. That was something is greater than equal to 0. Oh yeah, oh yeah. That's freaking okay, that's weird. Yeah. Unsigned are from 0 to 255, yes. It doesn't work since you have to count down to 0. So now it should work. Haha. Ha. Yes. Yes, it's doing its things. It's normal that the first cycles are screwed up, but whoops. Spoken too soon. Why is it doing that? Okay, I can see it sort of binary counts. Then it goes to 1111. Well, FFFF. It's attempting to do something. Did I do? I think I might have mixed up the Q and E pins. Let me swap them around. Let's do a reset. Nope. No, that happened. Okay. Though I have seen this. Somebody messaged me. Calm down, Bender. Twos don't exist. I need a bath and sleep. Yeah, François, it's not that late. It's only 9:44 plus 5 hours. Or is it 6? Well, it is getting close to 3:45. No. Sleep is overrated. Well, thanks, Rinky Dink. It's been a pleasure, François. If you have to go too, I understand. It's been a blast, and you've helped a lot. Thank you. I just need to figure out why it's doing that, but I think it's more of a hardware issue than it is software in this case. 6:44. Well, here it is 9:44. Then I would guess you're somewhere in the West Coast. All right. So why is it doing that? I'm trying to figure out. I've seen this before. It's also doubling the count. Right? It's like 1111 100 100.
It's trying. It's trying to do something. Let me check my. Let's go see with my top camera. Let's go switch things around and go to the benchtop and open the mic for the other side. All right, so let's got my probe there working, right? Yeah. High, low, good. So E and Q clock are working, which is a good sign. So that means the clock is working. Now, what about the values for the data? What do I have? Let's see, I have, so I said it's 0, it's 1, 2 for the opcode. So it should be low, 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 high. The next one, yes. Low, low, high, yes, low. So the opcode is correct. So that's not the issue. Opcode is fine. I'm not reading anything. I'm reading the bus, and it's not pulsing to right. So that's fine. And the input clock is on pin 38, which is the EXTOL, which is the external clock pin. So that's fine, because I've had weird dealings when it was on pin 39. I've made a mistake, but no, it's really on this pin. So it's pin number 0, 1, 2, 3, 4. Yeah, that's good. And data, let's see what it says here. So if I go to 0, it should alternate between between 0 and 1. I don't know if you can hear that, but it should have been a 50% duty cycle, but it's not. A1. So A1 should also be a 50% duty cycle, but twice as long as A0. So it's not the reading of the Arduino is not the issue. Let's do a reset on the CPU. It's really odd, because if I had an issue with the clock, I would not be getting a regular signal on E and Q. Right? You can hear that? If I bring the mic closer. That's E, and that's Q. And BA, BS are both low, which is normal operation. Right is high, which is normal. Pin 37 is what? Why am I getting a clock on 37? 37 is reset. Why am I resetting? That's the problem, is it's resetting constantly. So I press the button, it's low. Release, I'm in a constant state of reset. What's my voltage? Because the reset IC, supervisor IC, will reset if the voltage is not correct. And I have 5.1 volt, which is like okay. It's fine. If it was under like 4.75, then I would understand why it would reset. Oh, I think I may know why then. The supervisor reset does have the supervisor reset gets the signal from E-clock for the strobe input on pin 7, but if the strobe does not happen fast enough, then it will reset constantly. It's almost a second. If it's past 1.2 seconds and I program the supervisory chip to reset, to do a delay of 1.2 milliseconds and 1.2 second, then that would mean that it's resetting because the strobe input is past 1.2 seconds. So I need to use because we're going so slow. Normally I'll keep it at E, but because we're going so slow, either I increase the speed of the clock or I put the strobe on the clock output. That'll increase the speed. I'll leave the hardware as is. My calculation is 32.44 here. What the? Okay, I need to go. It's been fun. Thanks. Bye, Wayne. Sorry, you might be gone already. So who else is still there besides me, which is that's one. There's 3 other people here. Come on. Tell me who you are. Who are you? Who is still here? Trina! Yes. Don't forget to click the like. All right, so I think I know what the problem is. Hopefully. Let me switch back to the full screen. The reset IC, like I said, is the problem because it's under constant reset right now, and that's why it's doing that. So I will go faster so that the strobe, I will go instead of 100 milliseconds, I will go at 500. So that should do it. So it's going to be, no. Sorry, that's contrary. That's slower. So I should go, which is weird because technically after the print, it's no more than 250 milliseconds. Let's do 10. That should do it. Do it. If it doesn't,
I shall be stumped. Upload. Yes, that was it. It was too slow for the reset IC. Now it's binary counting as it should. Yes, success. I'm pleased. Well, you might not see it properly because it's 720p, but yeah, it's definitely properly counting. That's great. There. I'm happy. It works. Well, it's kind of weird, huh? Well, all I need to do now that I know it works, I just need to document it and put it in my video. I'll have to do like Ben Eater and rewrite the code and real fast and speaking. Okay, I'm doing this, I'm doing that without any errors. Everything's going to be fine. Fake a few errors here and there. Now, believe me, in the first episode, I didn't fake them. I really made some mistakes when I was doing the breadboard thing. But I am going to format everything properly so it looks nicer for the curly brackets, so it's easier to track and find things. So might as well do that now. But I'm happy that everything works. Ah, François, t'es toujours là? Je pensais que t'allais te coucher. All right. There. Clean the code so it's more readable, as Rinky Dink said. And François, I think you said that too also. I think I should probably put everything together in one line. What do you think? Oops. Is that better? Here it's going to look weird. Might as well put it in 2 lines. But, there, like this. Looks better. There. My wife just arrived from badminton. So there may be a time when I mute because she'll say, "Hello, honey." All right, so that's done. That's done. That's all right. Okay, nice and void curly bracket. The setup that we can remove. That's part of the standard stuff when you open a project. A sketch. And there. We are done. Perfect. Great. So I think, well, if people don't mind, I shall maybe stop the stream unless you guys want to see something else. Write it down in the comments. But it's been what? Well, 3 hours, like 3 hours and 20 minutes. Well, that's not too bad. That's going to increase. There's going to be a lot of storage space on YouTube just for this nonsensical coding. I don't know what you want to call it. Anyway, I'm glad you were all here. And thanks, Trina, François, Rinky Dink, Wayne. Who else was there in the chat? Going scrolling up. Scrolling. Ah, there was a lot of talk, eh? Oh, I'm Canadian because I said A. Oh, and
Dave, thanks for being there, and ABC DEFG, thank you. So I will sign off right now and see you in the next stream. Bye.